Okay, we've got a sample test here, and we're supposed to look at, for the given rational functions, determine the horizontal and oblique asymptotes. Okay, the degree of the numerator was 2, the degree of the denominator is 1, so this is going to have an oblique asymptote. So to find it, we have to divide this into that, and since it's a single factor, I could use synthetic division. But I can also do it long division. I'll do it long division. I'll do them both here. X plus 2 in long division. Put these in order. Minus 2x squared plus x plus 10. X times negative 2x would make negative 2x squared. So I'm going to multiply negative 2x times x. Negative 2x times that is minus 4x. Draw the line, change the sign so I can add. Those are like terms, they cancel. These are like terms, they get 5x plus 10, adding all this up. And x times 5 would make the 5x plus 10. Goes in evenly, draw the line, change the signs, add, I get 0. Don't have to go in evenly for the oblique. It actually is, the oblique asymptote is a slanting one that's minus 2x plus 5. It goes through 5, sloping down. Now I could have done it, since this is just a single factor, a single x plus 2, it has a root of minus 2, and I could have gone minus 2 into minus 2x squared plus 1x plus 10, and bring down the minus 2. Minus 2 times minus 2 is 4. Add, I get 5. Minus 2 is minus 10, 0. So my oblique asymptote is minus 2x plus 5. This one, the degree of the numerator is squared, the degree of the denominator is cubed. When the denominator is a higher degree than the numerator, the asymptote is going to be 0. Y equals 0. This one we have degree 2, degree 3, the degree of the denominator is greater than the numerator, so it's y equals 0. Now, if this had been cubed, it would have been minus 2 over 1, been minus 2. But it's the same, so that's the answer to that one. Okay. The equation for this. So for the numerator, I look for zeros. So for my f of x, it goes through negative 3, so it's x plus 3. And it bounces at 2, so it's x minus 2 twice. It has a vertical asymptote at negative 5, so this is where we get our vertical asymptotes tell us the denominator. And they're opposite, so it happens just once. Could happen 3, but it's probably just once. And so it's x plus 5 in the denominator. And looks like there's a vertical asymptote at 0, so that means x is a factor. They go the same direction, so that must be squared. And there's another one at plus 3, so there must be a factor of x minus 3. And see, the degree of the denominator is 1, 2, 3, 4, degree 4. And the numerator is x squared times x, x to the third, degree 3. So it's 4 and 3 with the numerator smaller. The horizontal asymptote should be 0, and it is. Looks like it's getting closer and closer to y equals 0. So this looks like a reasonable guess for the equation for that. Now we have one that's written in non-factored form, and we have to break it all apart. So we should probably start with graphing just the numerator. X to the third plus 2x squared minus 4x minus 8. And you can do this on Desmos or on the graphing calculator. And I should have 3 zeros, and it looks like I see all three. There's a double at minus 2, so that means x plus 2 is a factor twice. And it goes through plus 2, so that means x minus 2 is a factor. That's the numerator factored. Now let's factor the denominator. So that's 3x to the third minus 12x squared plus 12x. And let's go up and turn the first one off and graph that. And it looks like it goes through 0, so that means x is a factor. And it bounces at 2, so that means x minus 2 is a double factor. Okay? So, what does that tell us? Well, it looks like there's a whole at minus 2 if we cancel one of these. So, what would be similar to this would be x plus 2 squared over x times x minus 2. And since there's still of x minus 2 in the denominator, that means there's still an asymptote at plus 2. So even though it looked like there would be a hole, there's going to be an asymptote there, so there's no holes. Now, if this wasn't, it was just x minus 2 once and top and the bottom, then we would have gotten a hole, and to find it we would have plugged in that whatever that place is into the reduced form. Okay, vertical asymptotes. It appears that we should have a vertical asymptote at 2 and at x equal 0. This factor happens once, so it goes opposite at that place. One asymptote's up and one's down, depending on which way, and same here, they go opposite. So that's what I mean by the behavior. Do they go both in the same direction, or do they go in opposite direction? Okay? Determine the horizontal or oblique asymptote. Well, the degrees are the same, so it's y equal the ratio of the leading coefficients, which is 1/3. So that means the in behavior, as you get really far out, it gets closer and closer to 1/3. And maybe from the top or the bottom, but whatever. So I could include a question, what is the in behavior? Determine the x-intercepts. Well, the x-intercepts would whatever makes the numerator 0, except for maybe a hole, that factored. So it's going to be at 0, minus 2, 0 is a hole. The other one doesn't cause it. X-intercept. It's a problem at plus 2. Plus 2 gets canceled. Okay, and the y-intercepts, we put in 0, and we get negative 8 over 0, so there is none. That's because there's a vertical asymptote there. And so now let's do a sketch of the graph. So you need to have all the important information on it. No holes, x at equal 2 is a vertical asymptote. It goes in opposite directions on either side of it. And it has y equal 1/3 as a horizontal asymptote. And then it goes through x-intercept of -2, 0. And it does not hit the y-axis. So let's see. To be able to do this, it can't hit the y-axis because, oh, that's right. There's an vertical asymptote at 0. Forgot about that one. So it probably snuggles up to the horizontal asymptote in here, comes down and heads towards the y-axis, and it goes opposite here because we said it was a single factor up here. So if it's going down here, it must come from above. There's no x-intercept in between here, so it must come down and go back. And then, and I don't know how far down to come without looking at the graph. And then over here, so at 2, it's a single, so it's opposite, so it must come from below and approach this, but that doesn't make sense. There would be an x-intercept. It'd have to have an x-intercept if it came from below, so there's but it's a double factor there, so maybe it goes the same way. Okay, let's check it here, because now I'm confused. All right, on. We can do our check. I have the numerator in y1 and the denominator in y2, so I can just come over here. And the simple way would be to do it y1 vars, y variables, y1 divided by y variable 2. So it's just saying divide these two in there, and that's what it's going to graph. Oh. It went up, and then it went down, and then it stayed above. Yeah. Didn't have an x-intercept here, so it had to come from here. And, oh, let's see here. At -2. I didn't do the behavior of my x-intercept. That's what I messed up. This happened twice, so this is a bounce. I forgot to look at the behavior of that, so it bounced at -2. So it gets close to this, bounces at -2, so it goes up. There's my mistake. So then there was opposite here, so there has to be a piece down here, and then it comes opposite over here. So it's not in here, but down here. So I didn't notice the bounce here. I missed that part of it. So that's what the graph looks like. Determine any local maximum. Well, this comes down and then goes up. This keeps growing on the side, doesn't reach a max. This goes on. So there's a minimum there. There's a maximum somewhere in here. So and I can see it on my graph here, and I can calculate it by going second, calculate a maximum between 0 and 2, and my guess is at 1, and it says no, it's at 2/3, and it's -8/3. So my maximum is -8/3. The y value is the maximum. My minimum happens at -2, but it's 0 is the height of it. That's what I want. I've sketched the graph. When is this greater than or equal to 0? Well, all of this, it goes this way, bounces and goes up, so it's greater than or equal to 0 for x from negative infinity up to 0, not including 0, not including negative infinity. Then it's negative for a while, so don't want that. And then this part is greater than 0, so that's from can't be at 2, so 2 with an open parenthesis to infinity. Okay, kind of messed up my graph because I didn't notice that bounce, but that's that. All right, simplify if possible. Square root, so I'm looking for pairs. 20 is 4 times 5. Square root of 4 is 2. Square root of 5 is going to stay under. Square root of x will stay under. Square root of y squared would be absolute value of y. This cube root 81 is negative. See, 81. There's a negative, and then there's 3 times 3 makes 9 times 3 times 3. And we have a 5 on the outside and x to the 5th. And we're taking groups of 3, so we can take 3 3's out. A negative can be negative 1 times negative 1 times negative 1. So I can take out a negative 1's. So I got a 3 times 5 and a negative 1, so negative 15. And then 3 of the x's come out as an x. Don't have to do absolute value on odds. And I'm going to have left inside the cube root a 3 and x squared. And this says plus, and this is square root and cube root, can't mix them, so this just stays the square root of 3x. Can't do anything with that. Now, if I had the square root of 3x plus the square root of 3x, that doesn't become 9x squared underneath. This is adding. It would have been just 2 square roots of 3x, but I didn't have that. Might do that on a test. This one. So 12 is 2 times 2 times 3. And I got x squared, y 3. I have it squared, so I got it again, 2 times 2 times 3, and x squared, and y to the third. And I got to take the cube root, so I'm taking this to the 1/3. Groups of 3. Well, there's 2, 3 2's comes out as a 2. There's only 2 3's and a 2 left, so that's 9 times 2, 18. That'll still be under the cube root, or to the 1/3 power. I got 2 x's here and 2 x's there. I'm taking group of 3, so that's an x out, and 1 more in, so that's 3, number 4. And cube root of y to the third is a y, and another y, so y squared on the outside. So if you that would look like 2xy squared cube root of 18x, or 2xy squared 18x to the 1/3. Either of those answers are just fine. Solve for x. Looks like the common base might be 5. So I'm going to have 5 to the 3x plus 2 equals 5 squared to the x minus 3. And so when I got a power to a power, I multiply them. So I got, and the same base, so I can set the powers equal. So it's going to be 3x plus 2 equals 2x minus 6. So I subtract 2x, and I get x. subtract 2 from both sides. And there's my answer. This one, it looks like the common base will be 2. 1/4 is 2 to the negative 2. 8x is 2 to the third to the x, which is 2 to the 3x. This is 2 to the 1, and 2 to the x plus 5. When you multiply, you add the powers, so we got 2 to the 3x minus 2 equals 2 to the, adding 1 to this would be x plus 6. So therefore, 3x minus 2 must equal x plus 6. Subtract x from both sides. Add 2 to both sides. Okay. Determine the domain for this. Well, the inside has to be 0 or greater. So 2 minus x has to be greater than or equal to 0. If I add x to both sides, I get 2 is greater than or equal to x, or x is less than or equal to 2. That's the domain. Let's see, x less than or equal to 2, that would be from negative infinity to 2 if I ask you to write it in interval notation. In the cube root, we can take it of anything, so the domain is from negative infinity to infinity. In this one, if I have drug into the bloodstream is modeled by this equation, how much drug is in the bloodstream after 2 hours? So I can type in just type it in after 2 hours. So 3 times 2 is 6, divided by in 2 hours. So 2 squared is 4 times 5 is 20 plus 2 divided by 22, which is 0.27 nanograms per milliliter. What is the expected amount after many hours? The degree of the denominator is greater than the numerator. So for a large number of hours, this is going to go to 0 nanograms per milliliter, or ml. Okay? And that's the sample test.